Good day everyone, I'm Angeline Salvador and today I will be answering the third question, which is why is the sky blue, why is the sunset red, and why water is greenish blue.
Why is the sky blue? Despite how widespread this question is, there are many misconceptions and incorrect answers bandied about. In truth, the reason the sky is blue is because of the three simple factors put together. First is the sunlight is made of light of many different wavelengths. Second, the Earth's atmosphere is made out of molecules that scatter different wavelengths light by different amounts. And third is the sensitivity of our eyes. Sunlight is made up of all different colors of light. The photosphere of our sun is so hot at nearly 6,000 Kelvin that emits a wide spread of light from ultraviolet at the highest energies and into the visible from violet all the way to red, and then deep into the infrared portions of the spectrum. The highest energy light is also the shortest wavelength and high frequency of light, while the lower energy light has a longer wavelengths and low frequencies than the high energy counterparts. When you see a prism split up a sunlight into its individual components, the reason the light is split at all is because of the fact that redder light has longer wavelength than the bluer light. And the tiny invisible particles that make up our atmosphere is like nitrogen, oxygen, water, carbon dioxide, as well as argon atoms. Because these molecules are all much smaller than the wavelength of light itself, the shorter the light wavelength is, the better it scatters. In fact, quantitatively, it obeys a law known as Rayleigh scattering, which teaches us that the violet light at the short wavelength limit of human vision scatters more than 9 times more frequently than the red light at the long wavelength limit. So with all that said, you probably have one more questions. If the shorter wavelength light is scattered more efficiently, why doesn't the sky appear violet? Indeed, there actually is a greater amount of violet light coming from the atmosphere than blue light. But there's also a mix of the other colors as well, because your eyes have 3 types of cones for detecting color. Along with the monochromatic rods, it's the signals from all 4 that need to get interpreted by your brain when it comes to assigning a color. Each type of cone plus the rods are sensitive to light of different wavelengths, but all of them get stimulated to some degree by the sky. Our eyes respond more strongly to blue, cyan, and green wavelengths of the light than they do to violet. So even though there's more violet light, it isn't enough to overcome the strong blue signals our brains deliver. So the combinations of these 3 things: first is the fact that sunlight is made of light of many different wavelengths. Second is the atmospheric particles are very small and scatter the shorter wavelength light much more efficiently than longer wavelength light. Then the third is that our eyes have the responses they do to various colors. So these 3 makes the skies appears blue to humans' eyes.
And next is, why is sunset red?
So why is sunset red? The red color observed during the sunset is primarily due to the phenomenon called Rayleigh scattering. So when sunset passes through the Earth's atmosphere, it interacts with the molecules and particles present in the air. The atmosphere scatters the sunlight in all directions. But the shorter wavelengths of the light, such as blue and violet, are scattered more than the longer wavelengths, like red and orange. During sunset, the sun is lower in the sky and its light has to pass through a larger portions of the Earth's atmosphere. As a result, the shorter blue and violet wavelengths are scattered and dispersed to a greater extent, leaving mostly the longer red and orange wavelengths to reach our eyes. This scattering process causes the sky to appear blue during the day and allows the red, orange, and yellow hues to dominate the sunset sky. Additionally, the presence of other particles such as dust, pollutants, and clouds can further enhance the scattering and contribute to the intensity and range of colors observed during a sunset. These particles can scatter and reflect sunlight, creating a more vivid display of colors. It's important important to note that while relay scattering is the primary reason for the red colors of sunsets, other factors like atmospheric conditions, geographical locations, and even air pollution levels can influence the specific colors and their intensity during a sunset.
Next is, why water is greenish blue?
Why water is greenish blue? So water appears to be greenish blue due to combinations of factors including the absorptions and scattering of light by water molecules and suspended particles. The molecular structure of water causes it to absorb light in the red part of the electromagnetic spectrum, while allowing light in the blue and green regions to pass through relatively unobstructed. This selective absorption of light is responsible for the intrinsic bluish color of water. However, the color of water can also be influenced by the presence of other substances, such as dissolved organic matter, algae, and suspended particles. These substances can absorb and scatter light in various ways, affecting the overall color perceptions. Bodies of water such as oceans, lakes, and rivers, the presence of algae, particularly microscopic types called the phytoplankton, can contribute to the greenish hue. Phytoplankton contain pigments such as chlorophyll, which absorb light primarily in the blue and red wavelengths, reflecting and transmitting green light. This gives a water a greenish tinge, especially when the concentrations of phytoplankton is high. Additionally, suspended particles like sediments, minerals, or algae blooms can scatter light, leading to variations in water color. For example, in areas with a high concentrations of suspended particles, the water may appear more turbid or murky, which can affect its perceived color. Overall, the greenish-blue color of water is the result of the selective absorption and scattering of light by water molecules and the presence of the other substances like algae and suspended particles. The specific color of water can vary depending on the compositions and concentrations of these factors.
That would be all. Thank you for listening.